Hello and welcome back to this course on OpenCV 4 for secret agents. In the previous section, we built a face detector to help Benji, our secret agent, identify infiltrators. And now the enemy has fled, and we need to help Benji track the enemy's car. So we're going to help by building an object tracker. And to do that, we're going to first learn some basics of object tracking, and then look at all the existing trackers that can be used with OpenCV and use one of those existing trackers to then track objects in a video. So first up, some basics. So in this video, we're going to see what tracking is, what are the steps involved, and also see the different types of tracking algorithms. Object tracking is basically finding the motion path of an object over time. And to do this, we try to locate its position in every frame and try to track that position. So it involves first deciding on the type of representation and then detecting objects and then tracking. So we look at these in brief. First is the object representation. So this is basically done just so that the computer can have a representation that makes sense for it. So the computer needs a representation, something that it can understand before it can track an object. There are generally two kinds of representations. One is the shape-based representation and the other is an appearance-based representation. So in shape representation, as the name suggests, it tries to represent or describe the shape of an object. This need not be the actual shape of an object, rather just a way of representing that object. So for example, in point-based method, this is a kind of shape representation method, the detected object will be represented as a single point. So if you want to use point-based representation and say you are tracking a person, so maybe you will have the point thing that represents the person as one single point at the center, maybe somewhere. Or a ball, you're going to say that, okay, the center of this ball is going to be my point of representation for this object, and you're going to use that point as a reference for everything else. It could be the centroid of that particular object maybe, or the center. Similarly, if you want to track a car, maybe a rectangular box around the car is more suitable. That will be geometrical. So sometimes it can be an ellipse or any other geometrical shape. Similar to shape, there are different ways to represent an object based on its appearance as well. So silhouette or contour based representations can be used to form templates, and these templates will be appearance based. So, or even the probability density function can be used to get the appearance based representation. After object representation is object detection, and we've already seen what object detection is in detail in the previous few sections, so we're going to skip that and then move directly to object tracking. Object tracking algorithms can be broadly classified into three main groups, that is point-based approach or kernel-based tracking and template-based tracking. The same thing can be also said as region-based, contour-based or boundary-based kind of classification. We'll look at these three main types one by one. So the first is the point tracking. Point-based approach is generally used when the object is represented as a point. We spoke about shape representation, right? Where we say that the shape of the object will be represented as a point. So when you're using that kind of a representation, point-based tracking makes more sense. This is good in a way because it's not really subject to illumination, and it's more suitable when your object that you want to track is small, like maybe a ball, or similar in size to ideal if it's the size of a point, but then it's basically for smaller objects, not very big objects. Like maybe if you say truck and then you're trying to represent a truck with a point, that's going to be meaningless because it's such a huge truck and small. Whereas if you think about a small ball or something, maybe a point makes more sense. And in that case, point tracking makes more sense. But one disadvantage of this is that it needs object detection on every frame. So you need to keep detecting on every frame, then try to track. That can be very costly because detection takes a lot of time and effort. Some examples of this method are deterministic methods or statistical methods that are used by point tracking. In the kernel-based approach, the knowledge about the motion of object from one frame to another is used to determine its next position. And this is most useful when the representation is geometrical shapes like maybe rectangular or elliptical. One advantage of this method is that you don't need detection on every frame. You can do it once on the first frame. Once you've detected that object, you can use the same detection to track that object. In Silhouette tracking, the object models like color histograms or maybe object edge or object contour. This is one of the representations that we were talking about. These representations that are used in the tracking, right, those are created using previous frames. So you kind of have template or sorts, and then what you're going to do is you are trying to find a region in the current frame that matches this particular model that you generate using the previous frames. It's best suited for complex object shapes where, not simple ones like, circle, rectangle, or a point or anything, maybe complex object shapes, and then sometimes even complex movements of the object. When you look at point-based and kernel-based approach, they're mostly relying on the assumptions that the object, it's not going to move erratically, it's not going to move very fast, it's going to be controlled movement, it's going to be predictable movement. So, like I said, shape matching, contour evolution are some examples of Silhouette tracking. The main problems, or you can call it challenges in object tracking, is that it becomes very difficult if the objects are similar and you have to track. Like, the easiest example is going to be, say you have a lot of people walking around and you want to track one particular person. That's going to be very difficult. That is when the kind of representation you're doing and the kind of tracking you choose makes more sense, because you're trying to differentiate. So differentiating becomes a big necessity there. So if you take point-based tracking and say that I'm going to be detecting one particular person, a crowd, in a big crowd of people, then that's going to be difficult because there are a lot of people going to be close by, and then there is a lot of chance that it can misdetect and track some other person. So yes, it's important to understand what is the application and then try to get the representation and the kind of tracking algorithm based on your application. There are numerous libraries that implement a lot of these algorithms these days. If your aim is only to use and track, you don't track objects, you don't really have to go into the details of building an algorithm from scratch. There are already a lot of libraries that implement, and they are all either licensed or maybe free to use, free for educational or whatever. So you can use them and then build your tracker.